Hey guys, it's Mrs. Bryant. Welcome back to Flip Video. Before you begin, I need you to make sure that you have the notes for today, which should already be glued into your ISN, as well as that green foldable that you glued into your ISN. You'll notice that today's presentation I will have more slides than you have on your paper, and that's fine. Just make sure you're paying attention and copying notes down when I ask you to. So if you're ready to begin, let's get started. So you have this slide. It says a set of data is an ordered pair is called a relation. Functions are specific types of relations. So if you're looking at big picture ideas, relation is like the umbrella and functions fit underneath the relations. So look at the examples below and decide if they are functions or just relations. Remember yesterday we talked about what functions are and we knew that no input value could be repeated. So 4, 4, and 5, we know that those repeat and it cannot be a function, so it is a relation. And you do not have this slide, but you're just paying attention. We have 4 in this mapping, and it goes to -2, 1, 4, and 6, so this is just a relation. And then we have -1, 0, -1, so we know it's not a function, it's just a relation. So, like using a function machine, an equation can be solved for y by substituting a value in for x. And this should be a review of 6th and 7th grade. So when you're given an x value, you substitute it or you plug it in where the x is. So our example, and this should be in your notes, so make sure you are copying along with me, is y equals 2 times 3 minus 5. So y equals 6 minus 5, so y would equal 1. So when using function notation, this is a word you need to know, f of x replaces the y. We call it the fancy y. So instead of y, we did f of x equals 2x minus 5. So if you are substituting a value for x, it is written inside the parentheses to show it as an input value. So f of 3 would be x equals 3 is the same thing as f of 3. This is your x value. Whatever's in the parentheses is the input value. So let's do an example. Use f of x, or fancy y, equals 3x plus 4 to find f of 5, f of 2, f of 0, f of -1, and then we're going to put it in a table and we are going to graph it in a little while. So f of 5, here we go. F of 5 equals 3 times 5 plus 4, so that equals 3 times 5 is 15, plus 4 equals 19. So over here, we're going to put f of x, or y, is going to equal 19. F of 2, do exactly the same thing. Use the exact same equation. 3 times 2 plus 4, that's 6 plus 4, so that equals 10. Again with 0, 3 times 0 plus 4 is going to be 0 plus 4, so that equals 4. And then we have 3 times -1 plus 4, so that's -3 plus 4 equals 1. Now once you have your table, you can graph it and continue on. So here's where we're going to go with the table and graph, mapping and graph, sorry. So we had 5, 2, 0, -1. We had 1, 4, 10, 19. 5 went to 19, 2 went to 10, 0 went to 4, and -1 went to +1. So you know it's a function. And then if we graph it, we had 5, 19. So go over to 5 and go up to 19. 2, 10. 0, 4. negative 1, 1. And you will notice if you connect the dots, and I've already told you I can't draw in a straight line, it does pass the vertical line test. Okay, let's do another example. G of x, same thing as f of x, it's just a fancy way to say y equals negative 2x plus 4. So we're going to find g of negative 2, g of 0, g of 1, and g of 2. So negative 2 times negative 2, and remember, it goes where the x is, plus 4. So negative 2 times negative 2 is 4, plus 4 equals 8. Do it again, negative 2 times 0 plus 4, so that equals 0 plus 4, so that equals 4. Negative 2 times 1 plus 4 is negative 2. Plus 4. So that equals 2. And then negative 2 times 2 plus 4 is negative 4 plus 4 is 0. So let's do our mapping. We have negative 2, 0, 1, 2. And we have 0, 2, 4, 8. So negative 2 went to 8, 0 went to 4, 1 went to 2, and 2 went to 0. It's a function. And then we could graph it. Negative 2 went to 8, 0 went to 4, 1 went to 2, and 2 went to 1. And if you connect the lines, you know that it passes the vertical line test. So using your knowledge of what we just learned, what do you think you would do given the following information? Given the function f of x, or fancy y, equals 2x minus 5, and f of x equals 9, so we know fancy y equals 9, what is the value of x? So what are we trying to solve for? Well, we're trying to solve for x, because we know that f of x would equal 9, because it tells you f of x equals 9. So wherever f of x is, you're substituting what it says it is. It's outside the parentheses, so you know it's not going to go where x is. So let's solve this problem. F of x equals 2x minus 5. We know that f of x equals 9, so 9 equals 2x minus 5. And now just solve for x. So plus 5 plus 5. 14 equals 2x, divide by 2, divide by 2, so x equals 7. Alright, let's try another using the function f of x equals 3x plus 4, f of x equals 40. What is the value of x? We are going to do it exactly the same way. So f of x equals 3x plus 4. F of x equals 40. So wherever f of x is, we're going to plug in 40. 40 equals 3x plus 4. We'll solve for x because it wants to know what is the value of x. So minus 4 minus 4. You have 36 equals 3x. Divide by 3, divide by 3. X is equal to 12. So when x equals 12, you know your y will equal 40. So now we're going to work backwards. We're given the y's and we're looking for the x's. Remember, if I'm going too fast, you're pressing pause and making sure you're copying everything down. So f of x equals negative 5, so negative 5 equals 3x plus 4 minus 4 minus 4, so we have negative 9 equals 3x. So x equals negative 3. Do it again. Negative 2 equals 3x plus 4 minus 4 minus 4. So we have negative 6 equals 3x. Divide by 3, divide by 3. X is equal to this one a little bit smaller. 7 equals 3x plus 4. X is going to equal 1. I'll go ahead and give you that answer. And then 13 equals 3x plus 4. So it's going to be 9 equals 3x. Divide by 3, divide by 3. X equals 3. And now we can go ahead and map those and graph them. So our mappings are going to be -3, -2, 1, 3. And our fancy y's or f of x's are -5, -2, 7, and 13. And you will notice that it is a function. And if you graph it, -3 to -5, -2 to -2. I don't know why the gray line's there, sorry guys. 1, 7, 3, 13. So, is it a function? Yes, because it passes the vertical line test. Do not worry about the last example. If you want to, you can do it on your own. So let's go to this foldable. And let's talk about the answers. A relation is a set of ordered pairs where x is the input value and y is the output value. A function can be thought of as a machine that assigns an output value to every input. Okay? And so f of x is called the name of the function. This is the number that you plug into the function. And then lastly, f of x means the output of the function f when the input is x. We often refer to this as y. And this is actually the function. So let's look at the two examples that are at the bottom of that foldable. It says find f of 2. This is inside the parentheses. So you put it inside the function. So f of x equals 3 times 2 plus 4. So that equals 6 plus 4. So that equals 10. The second example is find x when f of x equals 7. It's telling you what y is. So 7 equals 3x plus 4. So we're going to do minus 4, minus 4. 3 equals 3x. Divide by 3, divide by 3. So x equals 1. That's it for the video tonight. Make sure you have completed all the notes. And make sure you have completed the 2 questions in the video survey. If you have any questions, you could text message me. Other than that, I will see you in class tomorrow. Have a great evening.